Hello and welcome to Sean White's Solar and Energy Storage Podcast. Today we have a sort of brother, maybe. His last name is White also. This is Will White. And I know actually I have other ancestors that are named William and stuff too, so we might be closer related than we even know. I'll have to go check on 23andMe. I have a 23andMe account, and then, that's how I used to screen my dates.
Make sure you're not related. Yeah. There you
go. And anyway, so let's talk a little bit about, that we're here at the InterSolar conference.
Yeah.
What's going on at this place. This is the last day of the conference.
It is.
It's in San Diego. It's been a beautiful day every day here.
It's been fantastic.
Yeah, even though it's like, right in the heart of winter in February, it's a great place to be. I love going to this conference here.
Yeah. Well, you get an advantage to start being from California. I'm from Vermont. It's been in the teens and 20s for the last 2 months. So coming to the 60, 70 degrees in San Diego has been fantastic.
Yeah, it's been great. Yeah, sort of like when I went to Panama last month.
Oh, there you go.
So, it was pretty nice.
Absolutely. Yeah.
So anyway, Will White is from Fluke.
Yep.
And Fluke is kind of famous for making measuring devices, I guess you could say.
Yep, absolutely.
I bought my first Fluke meter, I don't know, probably about 20 years ago.
Yep.
And it's a digital multimeter. It goes up to 600 volts DC. I think it was $300 at the time.
Yep.
And I haven't even had to change the batteries. I'm kind of
I think I've changed the batteries on mine. I get a clamp meter probably about the same time. And yeah, I still have it, still use it. And yeah, I think I've probably changed the batteries once.
Yeah, I don't even know, what kind of batteries is it?
AA.
Oh, so there's
almost everything is AA.
It's amazing that the AA batteries last that long. I've always thought too, when you're measuring voltage and stuff like that, you could set it up to charge the batteries as you're measuring.
That'd be pretty cool.
Yeah, figure that out.
Yeah, okay. I'll put that on the product innovation list.
Yeah, maybe that's what's happening. You just don't know about it.
Yeah, could be.
And how long have you been with Fluke?
I've been with Fluke since I started in November of 2022, so it's been about 2.5 years now.
Okay, great. I remember that they had me write some articles.
Yeah.
And it's been a little while. It must have been before you were there.
It was definitely before.
Yeah.
Yep.
And I don't know if maybe it was 5 years ago or something like that.
Yeah, probably about that time. Yeah.
And so I wrote articles about different meters and things like that. And then they gave me a meter that was like the irradiance measuring device.
Oh, yeah.
What do you call that one?
The IRR. Yep.
The IRR.
Yep.
Internal rate of return. No, that's a sales term.
Exactly.
So what does the IRR stand for?
I'm not exactly sure what IRR stands for. I think I'm assuming just irradiance.
Yeah,
it's probably just short for irradiance. Yeah, the version you have is probably the original one. The one we have now is the IRR2, which Bluetooth connects to our SMFT 1000, which is our solar multifunction tool that does IV curve testing.
Oh, wow.
So
okay, cool.
It captures the environmental data for when you're doing IV curve testing.
Oh, that's cool. Yeah, and I remember when I did those articles, and I was sort of doing a little consulting or something like that. And I think they were asking me what should we do for the future for the solar industry? And I was like, you should look into IV curve tracing and something like the Solmetric. And then so in the meantime, they bought Solmetric and made an IV curve tracer. So can I take credit for that maybe?
I think a lot of us get to take credit for that. My boss, who was involved in that acquisition, once it was announced, was joking with me that in my interview with him for Fluke, I said, you guys should really look at acquiring Solmetric.
Oh, great.
So I think there was a lot of people who had that same idea.
So they kept hearing it over and over again.
Yeah, and it's been, that acquisition was an excellent acquisition on both sides. We from Fluke brought in all that expertise. Willard and Mark, the co-founders from Solmetric, are super nice guys, still with us. They're working on our product innovation, our research and development team. Mark's working on software. A lot of people know Tom Danaher. Tom was the Solmetric support guy. Everyone I talked to, when I told them that Fluke had acquired Solmetric, they said, well, where's Tom? Because everybody knows Tom.
How about Peter Hoberg? Is he still with you guys?
I believe so. I don't know Peter. Paul Hernday, another one, does a lot of the Solmetric training, still working with us, although I think he's moving towards retirement at this point.
Yeah, Peter would come and speak with my classes at this place called Solar Universe that's not around anymore. Yeah. And I was doing a class there about once a month.
Nice.
And he comped me one of those. So I was sponsored. And I remember it was kind of funny too, they had this one Solmetric SunEye, the 210, I think it's called. Yep. And it was all beat up and broken. I was like, what's with that? And they're like, oh, we do destructive testing. And they throw it over their shoulder and stuff like that. just to make sure that it still works and stuff.
Sure.
So I thought that was kind of cool. And I remember they were like working out of Petaluma.
They were in Sebastopol.
Yeah, so yeah, those towns are right next to each other.
Yep.
And I know that's like where Enphase's headquarters is up in that area too.
I didn't realize that.
In fact, I think Peter Hoberg went to Enphase for a while, and I didn't see him forever, and then I saw him at a Solmetric booth, I don't know, maybe a couple of years ago or something like that. But I think there's also like kind of a neat story, or just like an interesting story about that. And I'll just kind of go from the start. Is at first, I'll just talk about like Zep Solar. I have some friends that were working there. So my friend Spencer, Chad, Duncan, and some other guys, working there with Zep Solar.
Yep.
This guy, I think his name's Jack West, started it. And everybody was using it. Like Sunrun was using it, Tesla was using it. And then
funny story with Zep. I was at, I forget the name at the time, because the company, I worked for a solar installer for 10 years. And acquisitions and mergers are name change. I think we were RGS Energy or Real Good Solar at that point.
Oh, you were Real Goods?
I was on the East Coast. So Real Goods had merged with Alteris Renewables, and I came from the Alteris side.
Oh, cool. Yeah, you mean Alti? Is that?
No, Alti is a different distributor. It was Alteris Renewables, which had been the merger of Solar Rights and Solar Works. You might know Lee Seddon from Solar Works out of Vermont. He was one of the old school solar installers.
Okay.
But I was piloting a Zep Solar project for our residential installer. We were going to switch to Zep when they were acquired, and Solar City had bought them out.
At least you didn't do it all.
And it immediately stopped. Yeah, so that was kind of interesting.
Yeah, so they had like this, or they still do have it, I guess, but it's like the module frame has this groove in it.
Yep.
And then it's a railless system, and then, they have this, I think this tool called a rocket.
Yeah.
And they would tighten down the bolt and it would go together, and it was like, your first time it took longer, but then once you got good at it, you could be really quick with it.
Yeah, that was the idea.
And then Tesla bought it. It was in the news, $158 million.
Yep.
And I think I heard some rumor that the guy that sold it, Jack, got like a first in line and got a new Tesla car and stuff like that, part of the deal. And so it kind of messed it up for all the other people that were using it, especially Sunrun.
Yep.
And so Sunrun was, maybe trying to get revenge or something like that, or just like to compensate. And so I think it was like with Sunrun, I can't remember, like in there somehow they merged with that solar company, what is it in Utah? Vivint Solar, yep. And so they bought Solmetric.
They did. Vivint had bought Solmetric. Okay,
so Vivint bought it.
Prior to the acquisition.
Prior to the acquisition. Okay, good. You're good at the history.
Yeah, and Vivint, my understanding is that they wanted to bring the shade analysis tool and integrate it into their software workflow. And they had the Solmetric team build essentially a version of the 210 specific to what they were doing, which they still have the intellectual property for that.
Yeah.
But then when Sunrun bought them out, they kind of didn't know what to do with Solmetric. So Willard and Mark bought Solmetric back from Sunrun. So they've done.
I wonder if they made money when they. How much they made?
Yeah, I don't know how much they made, but they definitely did well.
Yeah. So, and I think I heard of that happening in another case too. Was it like PV Evolution Labs or something like that got bought and sold and bought or something?
Yeah, I mean, it's the solar market. It happens so frequently. I mean, it was funny. I started in solar in 2005 working for a company called Solar Rights, which was originally based in Rhode Island, had expanded out to Massachusetts, Connecticut, and then it was merger and growth and merger and growth. And over the course of over 10 years with that company, I never got a new job, but we changed names about 4 times, expanded from just, we were literally working out of a walkout basement in Rhode Island with about 10 people. And at our peak, we were, I think, the number 3 residential solar installer for like a 1-year period.
Oh, cool.
And then, expanded to the West Coast with the merger with Real Goods. And it's been an interesting ride for sure.
Yeah, and so I always looked at that was kind of like a revenge buy. So I think also Vivint was using the Zep and all that. So it's like, let's get back at them, And,
well, Sunrun bought out Snap and Rack. I mean, they've owned Snap and Rack for a long time.
But it was kind of like, it wasn't like so proprietary or hard to switch over. I think it was kind of like a difficult switch over for these people that were just so geared up for the Zep.
Yeah.
And then, this railless system, and they have all these installers that probably never installed on a rail and all that kind of stuff. And then they took it off the market. And it was kind of distressful for a lot of people because it was sort of like back then, all of the financing required a Solmetric to take a picture. And so all of a sudden, this device that was like just over $2,000, the Solmetric 210, and by the way, just for people, it's this device that has a fisheye lens camera in it, like a bubble level that's digital, an inclinometer, and it takes pictures of what they call a skyline. So you take a picture, and it will tell you where the shading is going to be throughout the year. And so it can tell where you are, it has GPS, all that kind of stuff. And so people were selling them. I remember like having a screenshot for $5,000
like 4 or
on
5,
eBay.
Yeah.
And then quickly after that, people started figuring out different ways of doing shade analysis because that was kind of difficult to depend on. And also just like shout out, there's another device called Solar Pathfinder that's kind of
Pathfinder's
cool.
The classic.
Yeah, it's like the classic. It's like analog version.
Absolutely. Yeah, no, we were hoarding SunEyes at that time because I was working for RGS at that point. And same thing. I mean, all of our site survey technicians used them. And a lot of the incentive programs like New York, Connecticut, Massachusetts required that shade analysis, and then all of a sudden Vivint pulled it off the market. Then eventually they brought it back on the market and that price dropped back down.
Yeah.
Then we transitioned to more reliable satellite shade analysis. But we still have some calls for those on-site shade analysis, and we're working on the next version of that shade analysis tool.
Yeah, so where are we with that? Because the last time I checked, I don't think you could buy a Solmetric 210.
You can't. No, the problem with the 210 is that some of the internal components went obsolete, so we could no longer get the components to actually manufacture.
I remember like the device, like the 110, it was like you could just tell it had what was called a pocket PC in it. And it was sort of like the old Windows. I remember I had a pocket PC phone. It was like the first ever smartphone. It had a stylus and all that.
Yeah,
what was it? Half your time.
Was it a Palm Pilot, I think?
I think it was right after Palm Pilot.
Yeah.
And so I could go onto the internet, and it was like, I don't think it really saved me any time because it was just like always crashing and uploading it. This is like, let's see, what year? 2002 probably, or something like that.
Sure.
And so I thought it was kind of cool that they took it and then they put it into the Solmetric device.
Yeah, it was all built in. Yeah, the new version will be called the SunEye 360. It uses a 360-degree lens camera, so it's essentially 2 fish eyes. That you remember with the 210, you had to get it level and right in the right spot. So there was a lot of user error there. Using the fisheye lens basically completely eliminates that user error.
Okay.
So you don't need to worry about it being level or at the right angle. You just take the picture and it'll work with an app on your phone. So it'll be iOS and Android and Windows compatible.
Oh, cool. So it's 2 fisheye lenses. So just by the way, too, a fisheye lens takes like a hemisphere shot.
Yeah, exactly.
And so 2 hemisphere is a sphere.
It's 360.
And
so that's a product that's in early development.
So is it like a ball on a stick?
Yeah, essentially, yeah. It's a camera that's got the 2 lenses, one on either side, on a little selfie stick kind of thing with a little mount for your phone. And
Okay, cool.
Yeah,
awesome.
so that's in development. So
Are you developing it?
We're, not me personally, Fluke, our Fluke product team is working on it. And actually, the Solmetric team had developed it prior to the acquisition. So it's kind of one of those projects that's been a long time coming.
Yeah, I remember a couple of years ago, they were showing it to me, and it was like what I saw from what I remember a couple of years ago was it was like this stick with a phone on it, I guess.
Essentially.
Yeah,
and there's still some applications to that. I mean, we're obviously more focused on the IV curve testing tools and things that are used more commonly.
Sure.
The on-site shade analysis become kind of a niche
cool.
test.
So maybe tell us a little bit about the IV curve testing tools.
Yeah.
And so I remember that Solmetric had the IV curve testing tools. I remember they had some other cool things on their website too, that was like compound angle tool. Is that?
Yeah, they've had a couple of little niche things. I think those have kind of fallen by the wayside. The ones that we're focused on now is really the IV curve tool.
Okay.
So the PVA series, we have 2 models of the PVAs, the T2 and the HE2, both 1500 volt, 30 amp. The big difference, and this is something that a lot of people don't talk about when we're talking about IV curve testing, is high efficiency modules. So high efficiency modules have high capacitance. When you start the IV curve test, that results in a really high inrush current to the IV curve tool. So it has to do something with that power. Some tools like the Fluke SMFT 1000, where the efficiency exceeds about 19%, it sees that inrush as an overload short circuit current, and it stops the test from happening so it doesn't damage the tool. Some other tools on the market.
So maybe talk a little bit about that. So it's got a high inrush current, so like a more high efficiency module.
Yep.
No matter how big it is, it's just like.
Yeah, it's all based on the cell. So what happens is
the size of the cell or the efficiency of the cell?
Both, and they're usually related.
And so I know that like electricity travels close to the speed of light and all that kind of stuff.
Sure.
So why is it more so with a high efficiency module?
So it has to do with the amount of time. So you get a cell, it's a silicon cell. Sunlight hits the cell, it knocks an electron free. That's the photovoltaic effect. When it's not under load, over a period of time, that electron will recombine with the silicon. The amount of time that it takes for that electron to recombine with the silicon has an impact on the efficiency of the module. So the higher the efficiency of the module, the longer that electron is free before it recombines with the cell.
Okay.
So what that means is with a higher efficiency module, there are more electrons free in the cell when
that have not passed over, like.
Yeah, that have not recombined with the cell when it's not under load. When it's under load, it doesn't matter because the electrons are going to our inverter, producing the energy that's going out to our loads.
How do you know that? Can you see the electrons if you squint?
Oh, maybe you can. My eyesight's not that good, but yeah, no, it's cell physics, which is kind of beyond my area of expertise. But so with these high efficiency modules, there's a lot of electrons free, which leads to a high capacitance. So we see inrush currents to our test tool of like 200, 300, 400 amps for a very brief period of time.
Wow.
We're talking like milliseconds.
Okay, I didn't know that.
Yeah, no.
So you, like from a solar cell that's like somewhere around like 10 amps or something like that, you're seeing like 200 or 300?
Yeah,
or...
the high efficiency modules are usually somewhere between about 15 and 20 amps. Okay. But when you get up to that like 19 to 24% efficiency, yeah, you'll see an inrush current to the tool of a couple hundred amps.
Wow, yeah. And is that like for just like a millisecond or something
very,
like that?
Yeah, milliseconds. Yeah, very brief period of time. But for the tool still has to do something with that current. So some tools on the market will continue doing the test, but they'll either overheat and go into thermal shutdown, where you got to wait for the tool to cool down, or they're going to overheat and damage the tool, and then you got to send it back to the manufacturer for repair. So with the SMFT 1000, which is our solar multifunction tool, it can do IV curve testing up to 1,000 volts, 20 amps. When it exceeds about 19% module efficiency, it sees that overload as an overload short circuit current, and then it stops the test so it doesn't damage the tool. With the two PVA models, the T model, which is rated at 30 amps, when the efficiency exceeds 19%, we derate that current rating down to 10 amps. So if your efficiency is over 19%, the maximum current it can measure is 10 amps. And that's so that the tool doesn't overheat. The PVA 1500 HE2 is specifically designed for high efficiency modules. It's one of the few IV curve tracers on the market that can deal with those. It can measure any efficiency module up to its full 30 rated amps. So that model, so if people are doing utility scale projects, the HE IV curve tracer is really the way to go.
So how does it work differently?
It has different circuitry in it that is designed to absorb that inrush current.
Like some capacitors or something?
Yeah, and that's another interesting thing between IV curve tracers. There's essentially two ways to do IV curve tracing. There's resistance, which is what the SMFT 1000 does. That short circuits the string, takes a short circuit current measurement, opens up the circuit, applies a resistive load to it, closes the circuit, takes another voltage and current measurement, opens the circuit, changes the load, and it does that 128 times over the course of the IV curve.
Okay, so how long does that take to do the IV curve?
So that's the thing, with a resistive test, because it's constantly opening and closing that circuit, it takes about 32 seconds to run that IV curve.
32 seconds,
yeah.
wow.
So it's a fairly long time. And with resistive IV curve tracers, that's fairly common. Okay. So you'll see a fairly long test. With the PVA models, they use a capacitor bank, and it's a continuous sweep. So they start at short circuit current, sweep to open circuit voltage, and they're sampling along the way. And with the PVA, you can use or select either 100 test points or 500 test points. But because it's a continuous sweep, and because we're using the capacitor bank, super fast. It's like half a second.
Half a second.
Yeah, to do the 100-point test.
So you could do 60 tests instead of one if you're really quick.
Super fast, yeah. And once you get it set up, if you're in like an inverter or a combiner box with fuses, I mean, basically you're like closing one fuse, running the test, saving the results, opening that fuse, closing the next one. And we say you can run that cycle in about like 9 seconds or so.
Wow, okay,
so
cool.
It's super
So 9
fast.
seconds per string.
Yeah, to cycle through like close the fuse, run the test, save the test, open the fuse, close the next one.
Wow.
It's very quick.
And so for the resistance one, Does that thing heat up?
Well, and that's part of the reason why it takes so long, is because every time it closes that circuit, it has that inrush, so it's got to dissipate that heat. So that's part of the reason it takes so long.
So with that one, how long does it take, like instead of 9 seconds?
Yeah, I mean, well, it's 32 seconds to do the test, so probably add another 5 or 10 seconds to do the
you don't have to wait for it to cool off or something like that?
No, it can do it. As long as the efficiency is below about 19%, it can cycle through with no problem.
Pretty cool.
Yeah.
All right, awesome. And there's other IV curve testers on the market. Why is the Fluke's the best?
Yeah, I mean, Fluke tools are really designed for reliability and safety. So we have all the certifications for like the class 3 voltage ratings. So when you get into test tools, and I've got some training on this, there's categories. So category is the environment in which you're operating. DC arrays are considered category 3 environment. Our AC interconnection points are considered category 4. So all of our test tools are rated for the environment in which we're working. So the SMFT 1000 is category 3000 volt rated. The PVAs are category 3, 1500
so 3000 volt rated.
1000 volt. Category 3.
Oh, category 3.
1000 volt.
Okay, I was like, 3000.
An interesting thing when you look into things, especially like multimeters and clamp meters where you're measuring voltage, there are several meters on the market at this point that are capable of measuring 2000 volts. But when you look at it, what they really have is an adapter that goes from the test leads into the meter, and the meter is really 1000 volt rated. And what they're doing is reducing the voltage that the meter is actually seeing so they can read those 2000 volts. So they're not actually a category 3 2000 volt rated tool, they're a category 3 1000 volt rated tool that has an adapter that can measure that voltage. All of our tools are inherently capable of measuring the voltage. They don't need that external adapter. So all of our tools that are 1500 volt rated are category 3 1500 volt rated for that actual tool.
Okay, and just for some people, 1500 volts is as high as you get with the DC part of your PV array.
So far.
Yeah, and there's talk of going to 2000. And
yeah, 2000 will be the next step, and we've been keeping an eye on that for years, and there's been talk of 2000 volts for probably 3-4 years now. And I've always told my coworkers at Fluke that when we start to see modules rated for 2000 volts, then we know that the market's actually moving. And I believe it was InterSolar released a 2000 volt UL listed module a couple months ago. It's going to be commercially available, I think, about the middle half of this year, but it's the first UL listed 2000 volt module.
And are they using that with an inverter, do you know? Or?
Yeah, so GE's got a 2000 volt central inverter. Shoals has 2000 volt equipment. There's still some parts missing. We don't have 2000 volt listed fuses at this point. I know Stauble's got a 2000 volt rated MC4 connector.
Great.
So we're starting to see the industry moving in that direction.
We interrupt you for a very important announcement. Sean White's Solar and Energy Storage Podcast has been brought to you by Sean White's Solar and Energy Storage Podcast. That's right, Sean White is sponsoring his own podcast, and he wants to remind you to go check out some of his classes. You can go to SolarSean, that's Solar, SEAN.com, and then click on the links to check out his classes. You can check out his heat spring classes, and you can also hire him to teach classes for you, like at your company, something like that. Now back to the show.
It sounds like you've been in the solar industry for a long time. When I was going to meet you, I was like, oh, he's probably like been with Fluke for a long time, but you really know your solar stuff.
Yeah, so I started in solar as an installer in 2005. So actually this September, right around RE Plus, will be my 20th year in the industry.
Oh, wow.
So yeah, I started as an installer in 2005. I worked for an EPC doing mostly residential, small commercial stuff for a little over a decade.
Over in Vermont?
Yeah, Northeast. So I started in Rhode Island, moved up to Vermont, opened up a Vermont office for our company, eventually worked my way up to Director of Operations for the East Coast. So I was managing all of our installation crews in the East Coast. Then in 2016, I left that EPC and went to Solar Energy International, which I know you're familiar with.
Oh, okay.
So I worked for SEI.
Oh, okay. All right.
Yeah, I spent 6 years there, 5 years on the curriculum development team, updating and writing course content, teaching classes.
Awesome.
And then a year as Director of Business Development before I came to Fluke. Yeah.
Oh, cool.
Yeah.
Okay, I got it. All right.
Yeah.
Yeah, I might have recognized you from there or something like that.
Yeah, if people have taken SEI online courses in the last 5-10 years, they probably heard my voice.
Okay, all right, great.
Yeah,
okay,
yeah.
cool. All right, and so being up there in Vermont, do you know Solaflect?
I do, yeah.
Yeah, they hired me to come out there for a day one time.
Oh, interesting.
They took me around, and it was pretty cool. They had these 2-axis trackers.
Yep.
And it was like they have like a pole that sticks out of the middle.
Yep.
And then all these wires that go to it.
Sure.
And they have like, I think when I was there, over half the solar in their town was done by them, and they kind of had like a local monopoly, and it was like they repaired them and they did the whole thing. It was kind of cool.
This is an interesting product. Yeah, there's a residential house with 2 of them right around the corner from my house. But
And they can dump off that Vermont snow and stuff like that. And I think Bernie Sanders had something to do with getting their research funding when they first started off.
We've got quite a few kind of solar companies in Vermont. The bigger ones are NRG Systems. They make meteorological towers for wind studies and do stuff in the wind. And then we've got All Earth Renewables, which makes another tracker. They're a hydraulic tracker with the inverter mounted right on the tracker. So that's kind of an interesting product as well.
Very cool.
Yeah.
Awesome.
Yeah.
Okay.
Yeah.
So like with Fluke too, how long has Fluke been around for?
Fluke is, let's see, we celebrated 75 years a couple of years ago, so I think we're on our 77th year.
Okay, wow. And so like, what were people measuring voltage with back 75 years ago or 77 years ago besides their fingers?
Yeah, I mean, I think at that point it was large benchtop testers. I don't think there were a lot of portable meters at that point. So Fluke is named after John Fluke Sr. He's the one who founded the company in his basement in, I think, Connecticut. And he had actually gone to college with Packard of Hewlett-Packard. They were roommates in college. And John Fluke Sr. developed testing instruments in like his garage. And that's
all
how
this
the company,
garage culture.
Yeah, that's how the company got started. So Fluke's been around for 76, 77 years.
All right,
now.
cool. Do you guys still have some of those like super old
We do.
benchtop and all that?
Yeah. We've got a little kind of a little museum at Fluke headquarters, and we're based in Everett, Washington. We're literally right next door to Boeing. So we have a large building, and a lot of our assembly and manufacturing is done in Everett.
Cool.
So we get a lot of products that are domestically assembled of parts from all over the place. But,
very cool.
Yeah.
All right. Awesome. I'd like to go see that someday.
Yeah, it's super fun.
The old museum.
Yeah. It's an interesting facility both for that and to see kind of the manufacturing and how the manufacturing happens.
And so Fluke's not just a solar company, but they measure all the electrical parameters. What's like your highest voltage meter? Like
that's a
it
good
would be
question.
alternating current, I guess.
I mean, most of the stuff that we have is kind of handheld. I don't know on like the process manufacturing side if we have higher voltage meters, but the 1500 volt meters are kind of the highest handhelds that we have.
If somebody's going to go measure like medium voltage or something like that.
Yeah, we don't really get into that space. Most of our stuff is on the industrial, commercial, and residential scale.
If you took 2 different meters, and let's say you were going to measure 1500 volts, and you put 2 meters in series with each other, would they add up to 1500 volts?
Oh, I mean, they might, but the problem is the safety ratings. So we were talking about the category and voltage ratings. The big concern for testing voltage is transient voltage spikes. So you get those transient voltage spikes, which can be thousands of volts for very short periods of time. And if you happen to be measuring voltage when that transient voltage spike hits, you want to make sure that that meter is going to be able to withstand that voltage spike. Both so it doesn't damage the meter, but especially so it doesn't blow up, literally blow up in your hands. So having those category and voltage ratings ensure that that meter is going to be able to withstand that transient voltage spike. So if you took 2 600 volt meters and put them in series, they're not rated for 1200 volts.
Okay.
They're rated
but
for
let's say I
600.
had 2 1500 volt meters,
Yeah.
and I put those in series and measured 1000 volts. Would it be like 500 and 500 or something
I've never
like that?
tried, so I don't. I don't
It
know.
seems to me like if I just had to guess, I would guess that it would work.
Yeah.
Like, just
I don't
my
know.
guess.
Maybe I'll give it a try when I
It
get
might
home,
float around or something.
But
though.
I wouldn't recommend doing that.
I can't wait.
But-
I'm going to go home and do it right now.
Yeah, there you go. But the interesting thing, and Fluke had this little case study out for a while, and we pulled it. But what we did is we did destructive testing on our meters and some
So
competitors'
you
meters.
throw them over your shoulder?
No, this was
Solmetric?
like how much voltage can it withstand before it catastrophically fails. Like a category 3 1,000 volt tool, I believe has to withstand like a 7 or 8,000 volt transient. And most of the meters that we tested barely hit that threshold. Some of them didn't even hit that mark. The Fluke one was like 40% higher than what is required. So if it was like an 8,000 volt it was up to like 12 or 14,000 volts before it failed.
Cool.
So we really design our tools. We want to make sure that the people using our tools go home at the end of the day.
That's a good idea.
That's really our concern. Like we want to make sure that the people using our tools are safe, that the tools are robust and can withstand those conditions that they're working in.
Yeah, and like that meter that I bought, like 20 years ago, it hasn't broke. Like I've gone through a whole bunch of other meters, that I just like buy on the spot, like, let me go get this cheap meter, I'm in a bind or something like that because I'm traveling or whatever.
Sure.
And you set it wrong, you change the polarity backwards or something like that, and that's the end of it.
Absolutely.
It's disposable.
We hear that all the time of like, I inherited my father's meter that he bought in 1974, We get that story quite frequently, and then that's what you get when you pay for a Fluke tool. We're the first to admit that our tools are not the least expensive on the market. You pay a premium for Fluke tools, but that's why.
You got that reputation.
Yep.
And so I was wondering too, like I just always kind of like try to look at the future and what the future has. And so you have like IR cameras, which are really cool. In fact, when they gave me that solar measuring device, they're like, I think they were going to give me something else, and I go, I'd rather have that one, but I'd really rather have the one that can measure like infrared light, so you can pretty much it's like a heat camera. You can see in the dark and all that kind of stuff. And I have this theory that a phone eventually someday is just going to come with it, like the iPhone 25 or whatever. I'm not sure what year it is. Once they mass produce them enough and things like that. So I was wondering, like integrating some of the tools with a phone and stuff like that too. Or are we going to ever have a day where you just plug something into your USB-C and you can like start measuring voltage with it?
Well, so that's it's interesting you should mention that because we have a thermal camera that plugs into your phone. We have a Thunderbolts for iPhone and USB-C for Android, and we'll have the USB-C for iOS as well. Yeah, it's like list for $500, you plug it right into your phone and you get thermal imaging right on your phone. So we have that, and we've thought about that kind of modular plug into your phone for testing thing before. I think the big limitation we have is the listing requirements for those category and voltage ratings. When you look at our line of tools, like I like to use the clamp meters. When you go from 600 to 1,000 to 1,500 volts, the size of the tool increases. And that's because of the space requirements for the safety features in those phones. So I think the big limitation to doing something that plugs into my phone is the ability to meet those safety requirements. Now, that's not to say that we can't do something with software, which is something that we've really looked at. And Fluke software, we have a fairly diverse portfolio of software platforms. We're looking at kind of consolidating and getting all the data into one platform. We have a new chief product officer who comes from Microsoft and Amazon.
Heard of those places? Washington.
He ran the Xbox Connect product for Microsoft. He's amazingly talented, has a hardware and a strong software background. So I think you'll see a lot of our development focused on software. What I'd like to see is you go out, take a test, that automatically goes into the software. I can attribute that test to an asset, and then I can report that out. I can compare historic data. That's where I'd really like to see us going, and I think where we'll head in the future.
So I've heard of people using, like, say, a 600 volt rated meter to measure current with the clamp for like over 1,000 volts.
Okay.
Does that work? Or?
Well, so there's ways of doing it. So our multimeters, most of them are capable of measuring 10 amps. When you measure current through a multimeter using the probes, you're short-circuiting that circuit through the meter. So with a solar, like a string of solar modules, if I put my probes in the positive and negative and measure current, now there's current flowing through my meter.
Yeah, that would sound dangerous.
So what happens is as soon as I remove that probe, I'm breaking the circuit. So it's going to arc between the probe and your test point. It's going to damage the probe. It's going to damage whatever your test point is. And it's a safety hazard.
Maybe damage your eyes.
It could. So we always recommend using non-contact current measurements. So clamp meters are the way to go. You can get accessory clamp meters that plug into multimeters. So it's a non-contact current clamp for almost all of our multimeters. Okay. So that's a possibility as well.
But like, just like say mine, I have like the 337, I think it's called.
Yeah.
And I would just like, what if I clamped it around a circuit that was 1,000 volts, but I didn't touch the circuit, I just did it with my clamp.
Yep.
Does it matter how many volts the circuit is if I'm just measuring current?
That's a good question, and I've asked that question to our engineering team several times and not gotten a complete answer.
I've heard people doing it, yeah.
Yeah, and you can. The question is, if the insulation is compromised and voltage gets into that clamp, what's going to happen? That's my question. So I always recommend, if you're working on whatever system voltage you're working on, make sure you have a tool that's rated for higher than whatever that is. So if you're on 1500 volt systems, use a 1500 volt tool. Don't go and use a 1000 volt clamp to measure 1500 volt systems. Now, all of our test tools, if you measure a voltage higher than what they're rated for, you're going to get OL for overload. It's probably not going to damage the tool, but it's not going to read anything, so it's not going to do anything good.
Yeah, okay, cool, awesome. And so those infrared cameras, like what's the latest with measuring, IR, infrared, heat, all that kind of stuff?
I mean, there's not anything new per se as far as like super technological advancements. I mean, the resolutions get better. The IC is, for $500 for what you're getting there, is a pretty amazing camera. We've got cameras that go all the way up to, tens of thousands of dollars that get better resolution. So,
I'd love some of those.
No, they're really nice.
Just to play with.
Essentially, the higher the resolution you get, the further you can be away from your test point and still get good data. So for doing electrical work, I can be outside the electrical hazard zone, outside the arc flash zone, and still get good thermal images.
Cool.
So that's the advantage of those kind of higher end cameras.
And so one of the things that I do is I travel a lot, and I kind of always wish that I could get like a really small meter, but you were saying before that like the higher the voltage, the bigger the meter. So
Absolutely.
Like, there's not going to be any kind of like pencil-sized 1500 volt.
I don't think so. No, and we're looking at the move potentially in the future to 2000 volts. We're looking at 2000 volt tools. So we're looking at potential technological developments to reduce the size of that tool because they're getting just incrementally larger, and I mean you don't want to carry a big test tool. I don't either. Our technicians in the field, they don't want to do that. So we'll be looking at ways to reduce that package while still meeting the safety requirements.
Great.
Yeah.
And so one of the things that we were talking about a little bit was that when you're measuring current, if you did it through the meter and you pulled it off, it would make a big spark and things like that. And so another thing that people do with these clamps is they'll put it around a circuit before they pull the connectors apart, things like that, so they don't make a spark. And so I think it's be like a safety thing for people to know when they're measuring things. And so a couple of things is, a lot of people are just working with alternating current. They're not working with direct current. So if you just go buy a meter, it's probably like your average person out there going to wherever that's got a clamp on it, it's only going to measure AC. And as renewable energy gets, progresses more and more, we're seeing more DC measuring devices and things like that. So don't go out there and get a meter and not have it do DC, and then you're going to surprise yourself because you go measure something, you're like, oh, there's no current there, and there is, and you pull it apart and it makes a big spark, and it goes onto your retina or something, or not your retina, but your cornea, I guess you could say, of your eyeball. And then the other thing too is if I just took like a regular circuit, so you got like two wires in there, whether it's AC or DC, and you're measuring it, because you can have a meter. If it measures DC, it could also measure AC, but you have to have it on the right setting. But if you have the complete circuit, like say an extension cord or something like that, you're going to measure 0, because one electron's going one way and the other one's going the other way, because a circuit is a circle. So that would be just another safety thing for people to watch out for, to not think that they're measuring something and they're not measuring anything.
The thing I think about when you're measuring voltage is when you put the probes on anything, you're measuring the potential between those 2 points. So it's what is the potential between those 2 points, and really anytime you're doing any kind of measurement, you need to know what is my expected result. If I've shut my combiner box off and I'm going to open up those fuse holders and I'm putting a current clamp on each of those circuits before I open the fuse holders, I expect 0. If it's not 0, you've got a problem, and don't open up that fuse holder. Same thing for voltage. Like if I'm doing voltage testing, if my inverter's off, in most cases, if I test from positive to ground or negative to ground, I should get 0. If I have something other than 0, that's unexpected, and then I know that there's a potential problem there. But that's how we do that. That's what we do voltage and current testing for.
So let's see, is there anything else exciting going on at Fluke that we should talk about?
We've always got new products coming out. So we're going to have some new products coming out this year. We'll probably have those out for RE+. On the solar side, we're going to have a ground fault location tool. I'm really excited about this. We've been working on this for a while, and it's a testing technique that has not been used in solar for finding ground faults before.
Is it like a divining rod?
It's
how people find water?
Something like that. Yeah, it's something like that. But it's a test that hasn't been used before, and I think it's going to make it significantly faster, not just to tell if you have a ground fault, but tell exactly where the ground fault is. So that should be coming out middle third quarter this year.
Okay, and is it like secret how it works, or?
It's secret right now.
Did you invent it?
Yeah, I did not. No, I'm not that smart.
Why not? Yeah.
So
sure
that's
you are.
coming out. We've got some EVSE, electric vehicle supply equipment, testing tools coming out this year too, specifically for fast DC chargers.
Okay.
We've got the level 1 and 2 AC charger tester tools out now. The fast DC one will be coming out this year. So we've got that, and then we've always got projects in the pipeline. The interesting thing at Fluke is we do our strategy for the year every year. So every year we have about 4 strategic priorities. Solar has been a strategic priority since I think about 2018, and it continues to be. So we'll see more tools coming out specific for the solar industry.
Yeah, I think I've gone by your booth and seen like different, it looked like EV charger adapters and stuff like that. So those are all for testing.
Yep. Yeah, so the thing with EV charging stations is that they don't turn on unless they get a control pilot signal from the vehicle. So the only way to test a charger is to have a vehicle there, but that introduces some problems. First off, I've got to have access to an electric vehicle. It's got to be at a state of charge that is less than 100%, because if it's fully charged, the charger isn't going to turn on. And then it also adds a layer of issues to that, where now my troubleshooting becomes, is the problem with the charger or is the problem with the vehicle? So we have 2 test tools for level 1 and level 2 EV chargers, where they send the control pilot signal to the EV charger, it turns the EV charger on, and then we can do tests and measurement of those EV chargers. So we can make sure the EV charger is working the way it should be.
So does it have a battery in it then that you're charging?
It does not. It's not a load bank, although the DC charger tester will have a load bank capability to it. This is more like voltage frequency testing, testing the control pilot signal itself and make sure the control pilot signal is working the way it should be. Those are a frequency-based signal. And then we can also do things like ground fault interruption device testing, insulation resistance testing. So just kind of the basic electrical tests that we would do on an EV charging station.
Cool.
Yeah.
Awesome. Okay.
Yeah, we can use duty cycle measurements to figure out what the maximum current of the charging station would be, but we're not actually doing a load test on them at this point.
Okay, awesome.
But yeah, it's a big, I mean, anyone who has an EV knows that EV charging station reliability is an issue. So we're developing the tools to help people maintain those systems.
Yeah, it's like you go find some EV charger and it's a good chance it's not working.
Yeah. So we're trying to help.
You can tell by the bare wires a lot of times.
Yeah.
Copper thieves, all that.
Yeah, it's been a problem. And they're working on ways to prevent that. Tesla actually, and the Tesla EV chargers, when you cut away the insulation, they actually have Tesla stamped on the copper. So when they go to the recycling, it says like, owned by Tesla, returned to Tesla, so they know that was stolen copper.
Okay. I was thinking of changing careers to a copper thief. I guess. I guess I'll
crime,
have to keep doing what I'm doing. Yeah.
Yeah.
Thanks for letting me know so I don't get in trouble.
Yeah. They had another one that has like ink dye packs like built into the wire, so when you cut the wire, ink comes spraying out.
Oh, good.
That's the new technologies to help reduce that problem.
Yeah, I mean they could always just shock them.
I mean, that's a problem. I mean, that's the thing we have in solar too. I mean, they've got a lot of copper theft in solar as well. And that's super dangerous because if it's sunny out, that stuff's live.
Yeah, and I can imagine with all the attorneys out there, it's like some copper thief will make $1 million for getting shocked trying to steal something.
Hopefully not, but yeah.
Well, so let's say anything else. How do people get a hold of you, Fluke, all that?
Yeah, I mean, you can find me at pretty much every solar trade show. I'm there. The Fluke, and my email is just will.white@fluke.com. So
cool.
People can reach out to me there. I'm available to answer questions specifically about how our tools are used in the solar industry. That's kind of my specialty.
Great. Okay. Well, thanks, Cousin Will.
Great. Yeah. It was nice to sit down and talk with you, Sean. I appreciate it.
Yeah. Thanks a lot. And thanks for listening to Shawn White's Solar and Energy Storage Podcast. To find out more, go to solarsean.com and check out some of my classes. All right, get yourself NABCEP certified. Are you NABCEP certified?
Since 2006.
All right, see? You got to get yourself NABCEP certified, and then you can be like super smart, like Will White or Shawn White. All right. Take care.